So first of all, thanks a lot for the invitation and for the invitation. I'm very happy to be part of this nice venue. So today I will present a few results from a work we recently released. So it will be about environments and evaluation of agent, LLM agent. And maybe I will start with a very quick reminder about LLM agent because you may heard a lot about it today. So first, what is an LLM agent? So an LLM agent is just first an LLM, and what we call orchestration is everything around like prompts, context management. And importantly, an agent lives in an environment which is basically a list of tools. And in this environment, like the agent, like to fulfill some let's say user request, will emit tool code, like above, and the environment will execute those tool codes and provide an observation, like the result of the tool code as observation to the agent. And in this talk, I will rather focus on the environment part of this graph and not much more about agents. And in particular, I will try to answer which kind of environment we need to accurately evaluate an agent. So if we try to review a bit the different environments that exist. So first you have for instance the coding environment, like Swift, maybe some of you know it, where an agent has to solve some issue. So those environments are nice because they are reproducible. You can simulate everything and run as you want. And but they are a bit narrow in the sense that we only evaluate an agent on one capability, we only challenge it with code, code type. Another well-known family of environments are the web search one, for instance Gaia or more recently Moscow, where in this environment an agent has to answer a rather complicated question by doing web search. So these type of environments are also a bit specific. We only evaluate the search capability of the agent. They are a bit less reproducible also because web is evolving, so sometimes some questions are outdated and so on, so it's a bit an issue there. And also an important point is that environments are stateless. We do not have tools there that modify the state of the environment. We only have what we call redaction, so we only can retrieve information, we do not modify the state. And that's why somehow we have we can only test the search capability. Let's say a more holistic class of environments are the tool-use one, the FCL or to bench, where we test an agent on several capabilities. For instance, search, classify it as search, as you saw before. Execution is when you want the agent to execute a kind of long sequence of code. They are most of the time reproducible because simulated. Stateful because you have tool to modify the state of the environment. For instance, here book reservation will change the state of the environment. But maybe one of the last drawback of this or the current issue with those environments is that they are synchronous, meaning that the environment is paused when the agent acts and does not really reflect what happened in reality when you deploy your agent and you just interact with it. So what we rather want is asynchronous environment, and that's why we developed this ARE platform. So this is a platform to be able to develop benchmarks that satisfies all those criteria, holistic, asynchronous, reproducible, and stateful. And this is mostly so we are able to re-implement old benchmark, but also to implement new and to evaluate like agent at scale. But you can also use it, for instance, to generate data to train an agent. But I will not talk too much about this part. And we use this platform to create like a new benchmark called Gaia 2. So it's a bit linked with like the previous you saw before. And with kind of a focus on the temporal reasoning of an agent capability. So we want we want to leverage the asynchronous feature of this platform to generate environments that are asynchronous, where we can test the agent on tasks that where you have like temporal constraint, and that where like the environment can evolve during like the agent is executing some tool. And we did like an empirical study where we evaluate some like proprietary open source model of it. I will talk in detail later. So, so the platform like rely on some core principle. First, we have what we call an app. So an app is just like a list of tools. You can think of like email app, where you have like send an email, fetch like receive email, and so on. And they have a state. The state is like the data linked to these tools, like the history of emails, things like that. And we also have this notion of events. So in this platform, like or in this like environment, like built with this platform, everything is an event, like a tool call by the agent or also by the user, but also change of the environment that can be like triggered like or scheduled. For instance, if you have like you want like the user to receive an email at a certain point in time, or like with respect to certain condition. So that's what's an event, and the environment basically is like it's on site, and it's just like a queue of events that are processed by this loop. And we will just like generate like feedback or like a tool response to the agent, but also like notification when like the environment change. And what we call scenario. Scenario is basically kind of like an elaborate way to say like a task. So it's like an initial states for all the app, some schedule events, in particular the user query, and some verification mechanism. Okay, so yeah, so I will not go too much into details, except that yeah, well, importantly we classified like all the tools in two types. There is one that are the tools that where you just like kind of retrieve information and they do not modify the state of the environment, and the right one which modifies the state of the environment. Okay. Events, yeah, so I will not go too much into details also, except like we have a particular class of events that we call heroical events. They are kind of like special one because they are never like processed. It's only like ground truth, right action that are used to validate if like the trajectory of an agent is like solves the task or not. So you can think them as like a kind of reference right action that we will use at some point. Okay, so a scenario looks like that in the UI. So we have, as I said, like the app, the schedule event, so it's like that. Here, let's say we only have like a user task, and here some those oracle events, which are like things the agent needs to perform. Not it's only right action, so only like modification of the state of the environments we put there. Okay, so this is a quick example, so you can see the flow, and like the most important thing here it's like this asynchronous feature where while the agent is running, something can happen in the environment. For instance, you receive an email and you need to react to it. Okay, and with this platform, so we build a benchmark. So first we get one environment, which is kind of like a smartphone-like environment. So you can you put like all the apps you can think of in a smartphone, like emails, calendar, contacts, and so on. And importantly, we also provide like synthetic data for all those for this environment with like several like personas. So it's centered over here like 10 persona. So we have like emails, and message history, contacts, and so on. So it's kind of like a as it's called, like a whole universe, like centered around someone. And for like this benchmark, we use like a default orchestration for the agent. So the orchestration is like what we put around the LLM to get an agent, as I said. So it's based on the React framework. So React is just like the agent will alternate between sort and tool call, and like in a kind of infinite loop. And we just add some functionality to handle asynchronous environment. In particular, the agent can now like pause itself to wait some like event, like pause until you receive a certain notification or something like that. And for the verification, again, I will not go too much into details, but we leverage those like Oracle events I talked about before. And we use kind of a mix between LLM judge and like exact match of like tool call parameter to evaluate the agent. And yes, as I said, like we only look at write action, so the agent is free to do anything for retrieving information in the environment, but write action, which are considered on behalf of the user, you need to make, like, to follow exactly what is prescribed in those Oracle events. Okay. And so the benchmark itself, so we have like a 800 unique scenario made by human annotator, so it runs through like several rounds of verification and evaluation. And they all live in this like mobile environment I just present. Yes, all of them are like verifiable. So we have like a way to say that once like we launch the agent on it, if it succeeds or not. Okay. And we targeted like few capabilities, like the one I mentioned at the beginning. So maybe like the most classical one, like execution and search. The execution is basically, as I said, like you have to do like a long sequence of write action. For instance, here in our environment, it's like update all my contacts with some condition. For search, is you have to retrieve some information in the environment. Usually, like so you need like several tool calls because it's a bit hidden. Like what's the example here? Which city most of my friends live in, things like that. And maybe less like classic capabilities, which are ambiguity and adaptability. So ambiguity here, like the task is unclear or maybe impossible. The agent has to realize this thing and go back to the user with a clarification question. And for adaptability, now like it's really linked to this synchronous feature. The agent has to react to some like change in the environment. For instance, yes, like do something when I receive an email or something like that. And maybe a new capability which was not present in previous benchmark is like the time one, where we ask the agent to complete task in due time. So after I received, like, if in 3 minutes someone did not answer, like do something. And we have also two capabilities, but I will not present them too much. Like one that evaluates multi-agent framework, so where each app is replaced by an agent. So the, let's say, master agent has to interact with all those app agents. And noise is like for robustness, where some tool calls can do not like execute correctly. And the results are the following. So yeah, we try to evaluate like as many as possible models, but there are like many recent release, so it's not maybe completely up to date. But the first remark you can see is that reasoning helps in general. We have better score with reasoning model. It's not like the same thing for all the models. For instance, if you look at Claude Sonnet, adding thinking does not help that much, but for GPT-5, it's very important. You go from this side to the best model. And yes, maybe another remark is that the property model still dominates this benchmark. If we try to see per capability, so for the classic capabilities like execution and search, we can see that they are almost solved by frontier model. So those two plots there. There are some we can notice some overfitting. For example, for Grok 4, here it's very good in search, but it kind of collapses on all the other capabilities. So it's nice also to see such thing. For those less classical capability, ambiguity, and adaptability, it's still challenging for most of the model. And for the time one, here we see that there are very few models with significant score. And I will talk a bit more about it later. But before, maybe we can just check that thinking model or thinking really drives performance. So for that, we just plot the performance versus the number of output tokens per scenario. So we see that we have a clear correlation between performance and the number of tokens used. But we have some outlier, for instance, Claude 4 here, Sonnet. It does not output that much token, but it's still very decent performance. And we see also that this model kind of compensated, if you look at this other plot, by doing many tool calls. So it's since the right action are kind of blocked by verification, this model is just doing a lot of read action to compensate the thinking and be able to perform the right action. Okay, but if we know, take into account the cost, it's the picture is much less clear. You see that, for the GPT variants, so higher cost leads to better performance, yes, but it's also much slower. And remarkably also, for Claude 4 Sonnet, we saw that it output much less token, but we could expect it to work well in this comparison also, but it's not the case. The price is still very high, even if the model is much faster. And in terms of open source model, DeepSeek and Terminus and Kimi K2 are maybe very good choice, at least for this benchmark. And again, we see Grok 4 is maybe not a very good choice. And kind of the same thing now, we plot the performance you have if you have constraint on the budget per scenario. So let's say if you have a small budget, then going with GPT OSS is a good choice. For intermediate budget, open source model, Kimi K2 are maybe the best one. And if you have kind of very high budget, going with property model, are also a good choice. And so for time, this if we try to investigate a bit more, the main conclusion is that yes, reasoning takes time, and for instance, if you change if you simulate the fact that like the time to generate an action is instantaneous, so you remove like the time used by thinking, for instance. This is this like instant mode here. You recover like the same ordering of like models as before. But once you go back to the default mode, so when you take into account like the time used by the model to think, then you see that yeah, only Claude 4 and Gemini gets some like not completely bad result. And this kind of asks for maybe new research direction in terms of like adaptive compute for models, but also new orchestration, like with parallel tool calling or like multi-agent setting. In particular, some scenario in times you will be not possible without at least parallel tool calling. And to conclude, so like the key points that we have like built this platform, so we hope that it will be useful like to create new benchmark and allow people to build their own like evaluation of agent. So as I said, it will also be useful to generate data. And with like this focus on the asynchronous environment. And with this platform we built this like new benchmark where we see that like classical capabilities are kind of solved, but there are many that are still like challenging. And in particular, like the time one will, I think, request like new things like to be solved. And yes, thanks a lot for your attention. And here, like a list of like amazing people that works on this.